Okay, welcome back to the review session. This is number 9 on the review packet. Number 9 on the review packet. This is a little complicated problem, so I'm going to use a bigger piece of paper and then on a separate piece of paper, and we're going to work this one out for you. So let's start with this one. So here it says for a irrational function, you got this expression here. Now here, then part A says, prove that the radical square root of x plus 5 represent a rational number when x is equal to -1, but an irrational number when x is equal to 1. Okay, well, so here's the thing, right? Rational number is any number that can be expressed as something over something, a over b. So if you can express it that way, that's a rational number. So in this case, when x is equal to -1, for square root of x plus 5, you end up with square root of -1 plus 5, which is square root of 4, which is 2, which is 2 over 1. Yeah, this is rational. That's not that hard to know. When x is equal to 1, what happened, right, is you end up with 1 plus 5, which is square root of 6. That's it. Square root of 6 is square root of 6. You cannot express it in a fractional form, right? You cannot express it into some sort of nice and neat digits of a over b, integers over a over b. So that's why it's called the irrational number. Okay, so there you go. All right, part B says, what kind of number does x plus 5 represent when x is less than -5? Well, x plus 5, when x is less than -5, when it's less than -5, think of it this way. When you have, that means you end up with square root of a negative number, right? -5 plus 5 is equal to 0, so you end up with square root of 0, which is 0. But if you had, say, less than -5, say -6, you end up with square root of -6 plus 5, which is square root of -1, which gives you, which is not a real number. And when you have a square root negative number, this becomes an imaginary number. Okay. Part C. For what values of x is the denominator fraction equal to 0? What do you suppose happens to the graph of f at these values? So let's take a look at the denominator. So denominator, we got 3 minus square root of x minus 5. And we want to set it equal to 0. Okay, set it equal to 0. Now, if we do that, then we can say 3 is equal to square root of x minus 5. So then that's square on both sides. That's right, to solve for x. So we end up with 9 is equal to x minus 5. Then x is equal to 14. Okay, so now let's check. 3 minus square root of 14 minus 5 is equal to 3 minus square root of 9, which is 3 minus 3, which is 0. Okay, so there you go. But if that's the case, then you end up with f of x. Well, you end up with f of x equal to 1 over 0 minus 2, right? Because the original equation is 1 over that expression, which is the one that we just set equal to 0. So it becomes 1 over 0 minus 2. 1 over 0 minus 2. And if you have 1 over 0 minus 2, you end up with undefined value. And we had talked about this before, is that whenever you have a graph of 1 over 0, you are going to get an asymptote. And in fact, it's a very specific kind of asymptote, which is a vertical asymptote at x equal to 14. At x equal to 14. Okay? At x equal to 14. So part D, here says, write a domain. So if I combine, so domain here, right? Domain is, number one, we say, okay, so x cannot be 14, right? Because that's when, this is where the asymptote is happening, vertical asymptote. And we found that in part C. Well, what about part B? Part B shows us that x cannot be less than -5. So that means x has to be bigger or equal to -5, right? X cannot be -5, right? We just said it. Because if x is negative, x is less than -5. If x is less than -5, you end up with an imaginary number. So x has to be greater than or equal to -5. Your domain will go from -5 to 14, right? But it includes the -5, but does not include 14 because 14 is an asymptote. And then you go from 14, not including 14, and go all the way to infinity, and that's your domain. There you go. All right, now the next one says part E. Part E, you want to write this f of x as a singular fraction form. So here I'm going to switch paper, and I'm going to show you the process. Okay. And I actually have this solution written out, so I'm going to just go ahead and show you how that works. So I'm supposed to write this. Function. Let me just cover this up a little bit better. I'm supposed to write this function as a singular fraction. So the way I do that is I look at this and I say I had to conjugate the bottom because I have a radical on the bottom. So what if I do 3 minus, so you got 3 minus square root of x minus 5. So if I multiply 3 plus square root of x minus 5, then I'll have a difference of square. So take a look at this. I will multiply by the conjugate, right? 3 plus square root of x minus 5. But if I multiply on the bottom of a fraction, I need to multiply the same thing on the top. And the minus 2 is still over there. If I do that, you end up with a minus b times a plus b, right? So it's a squared minus b squared. So on the bottom, it becomes 3 squared, which is 9, right? And then square root of x minus 5 squared. And on the top is this one. Okay, you follow? And then, so then after that, right, the bottom, the square root here drops out, so you got 9 minus parentheses x minus 5. Top is 3 plus square root of x minus 5 minus 2. Let's keep going. So I dropped the parentheses because there's a negative in front of the parentheses and there's minus, so then here it becomes there's a plus right here. So far so good. And then I combine the 9 and the 5. I end up with a 14. I end up with a 14 minus x. 3 plus square root of x minus 5. Now, because this is a negative 2, so I had to basically find a common denominator. And common denominator is 14 minus x. So the top is 2 times 14 minus x. So now I have the common denominator. So when I do a common denominator, and then I combine the numerator, and that with 3 plus square root of x minus 5, minus, right? 2 times 14 is minus 28. Negative 2 times negative x becomes positive 2x. Further simplify this. This ends up to be my solution. Right there. Make sense? Okay. Lastly, now this is a long problem. It takes a while to finish this problem. So, lastly, here says find out whether or not there are any x-intercepts. Right? There's x-intercepts. When you have x-intercepts, that means f of x is equal to 0. So, right here, I set f of x equal to 0. These are the x-intercepts. Now, the f of x equals 0, I can now use the simple, my form right here, right? This simplified form. Well, I want to set this equal to 0, then I don't have to worry about the bottom. Right? I just know that bottom, x cannot be 14 because it will make this undefined, which I already knew from previous parts, right? But in this case, I just need to set the numerator equal to 0. That's the reason why over here, my numerator, I set that equal to 0. So 2x plus square root of x minus 5 minus 25 is equal to 0. Now, what I can do is I can keep the radical over here, right? Square root of x minus 5 over here. I move the 2x and the negative 25 to the other side. So this is what I got. Square root of x minus 5 equal to 25 minus 2x. Now, this is just a matter of getting rid of the radical, so I square on both sides of the equation. Right? The radical goes away. I get x minus 5. And I have 25 minus 2x parentheses squared. And you factor it out. Then you end up with x minus 5, 625 minus 100x plus 4x squared. Then you end up with 4x squared minus 101x plus 630 is equal to 0. Pretty complicated quadratic equation. No worry, no fear. Just use your quadratic formula, and you can even use a calculator, and you can come up with 11.25. Okay. On the test, I won't expect you to spend so much time on just solving the quadratic equation. So even if you set it up to this point, and then you simply say, right, use quadratic equation, and then leave it as that. If your process leading up to this point is logical and accurate up to this point, you'll get it for credit. Because I don't want you to spend way too much time just trying to figure out the numerical answer. What I care most is whether you know how to logically go about finding the answers, and not necessarily the actual answer in of itself. If you can do this, I know that you really have a mathematical sense of how to think about this function, this types of function. Okay? All right. See you in the next video.